Good afternoon, candidates of 2024. I am Mr. Magoloma from BCM Inner City, the physical science teacher. I am going to take you through question 7 of paper 2, physical sciences, which is acids and bases. Acids and bases were discovered by two scientists. The first scientist is Arrhenius theory. The second one is Laurie Bronsted. Arrhenius defined an acid as a substance that produces hydronium ions. He also defined a base as a substance that produces hydroxide ion. The second scientist, which is Laurie Bronsted, defined an acid as a proton donor and a base as a proton acceptor. There is an examinable question in this concept which says why Arrhenius theory is not widely used. You respond in this way, candidates. Arrhenius theory is not widely used because he focuses on reactions that take place in the presence of water. Then we have strong acids and weak acids. The commonly used strong acid is nitric acid, sulfuric acid, as well as a hydrochloric acid. And the weak acids are organic. In order for you to understand that if a certain compound is organic, if that compound it has a carbon bonded into another carbon, you can make deductions that that particular compound is organic. Then there is an examinable question that will say why you are saying a certain acid is a strong acid. You respond in that question in this way. Sulfuric acid, for an example, it is a strong acid because it ionizes completely in water to produce the high concentration. It is very important to understand in this way that acid, the keywords when you are dealing with acids is one, is that they ionizes. Number two, they produce hydronium ions. Then when you are dealing with bases, the keyword there is that bases, they dissociate. Number two, they produce hydroxide ions. Now the strong acid ionizes completely in water to produce the high concentration of hydronium ions. The weak acid ionizes partially in water to produce the low concentration of hydronium ions. Then when it comes to bases, the keyword in bases is dissociate, and number two, they produce hydroxide ions. Then the difference between the strong base and the weak base is that the strong base dissociate completely in water to produce the high concentration of hydroxide ions. Then the weak base dissociate partially in water to produce the low concentration of hydroxide ions. Another examinable question in this is that you will be asked about the acid proticity. Acid proticity simply means that some acid has an ability to donate with more than one proton. In acid proticity, we have three types of acid proticity that are relevant for the candidates of grade 12 or grade 12 learners, which is the monoprotic acid, which means that an acid has an ability to donate with one proton. Mono means one. Diprotic acid, it means that the acid has an ability to donate with two protons. Then the third one, that's a triprotic acid, which means that that acid has an ability to donate with three protons. And one other thing that is very important, that you will use it when you are required to calculate a pH. You need to understand that a monoprotic acid is just a one-step ionization, right? It will help you get candidates to find a ratio. Remember, when you are required to calculate a pH, you are given an acid. You always find the concentration of hydronium ions. Then when it comes to diprotic acid, it has a two-step ionization. And once it has a two-step ionization, you need to find an overall. Then when you are required to calculate a pH of a diprotic acid, you use an overall to find the ratio between the acid and hydronium ions. As I've said earlier, that always when you are required to calculate a pH, you must always find the concentration of hydronium ions. As well as a triprotic acid, it has a three-step ionization. You will have step number 1, step number 2, step number 3, and the overall. Then to calculate the pH, you will use the mole ratio between the acid and the hydronium ions so that you get the concentration of hydronium ions. And another thing that is very important when you are dealing with acids and bases, it's when you are given either the diprotic acid and or a triprotic acid, is to understand ampholyte. Ampholyte is a substance that acts as a base as well as an acid. In this concept that I'm about to explain, candidates, learners, they usually make a mistake of saying the ampholyte in a reaction is always water, right? I believe and I also understand that water is amphoprotic in nature. But if, let's say, you are given a sulfuric acid and you are given the equation number 1, first ionization step, and the second ionization step, the question will say, from the above two equations, which substance serves as an ampholyte? In that case, you need to do what is called the reaction analysis. In reaction analysis, we are actually checking this substance serves as an acid, it serves as a base, it serves as an acid in reaction number 1, acid and a base in reaction number 2, acid in reaction number 2, as well as a base in reaction number 2. Then, how do you see that if this particular substance is an ampholyte? In reaction number 1, it must be acting as a base. And then in reaction number 2, it must be acting as an acid. Or in reaction number 1, it must be acting as an acid. And in reaction number 2, it must be acting as a base. Then we move into one of the key concepts that you must understand about the hydrolysis of salts, which is defined as the reaction of salts with water. That is a correct definition from Examination Guidelines 2021. There is a question there that will ask you in the exam where you are given a salt, then they say, with the explanation of the balanced equation, explain that the resulting solution of a certain salt or particular salt is acidic. Listen, you need to have this clear background in mind of how salts are formed. Salts are formed as a result of an acid and a base reaction. For an example, if you can take we can take a CH3COOA, all right? Then when you trace the background of that salt, the reactants was ethanoic acid reacting with sodium hydroxide. Ethanoic acid is a weak acid and sodium hydroxide is a strong base. Then in this case, if you get this correctly, you will be able to see that the resulting solution is going to be basic. All right? Then how do you do that? When you dissociate this salt in water, then the first part, which is the conjugate that is coming from the weak acid, is going to be a strong conjugate base. And then the conjugate that is coming from the strong base, it is going to be a weak conjugate acid. And we always take the strong conjugate and we react that strong conjugate with water. Remember, the water is amphoprotic in nature. It can react with an acid and it can react as well with a base. In the presence of an acid, the water becomes the base, and in the presence of the base, the water becomes an acid. And in that way, once you see that on your product, on your second reaction now, on your product you see that there is a formation of an excess hydroxide. It tells you that the resulting solution is basic. Once you see that there is an excess hydronium ions, it also gives you that the resulting solution is acidic. Then another thing that I want to remind you candidates, it's how to choose the suitable indicator in acids and base titration. It mainly depends on the reactants. Are you titrating a strong base with a weak acid? For an example, we are titrating sodium hydroxide with ethanoic acid. Then the suitable indicator in that case is phenolphthalein indicator. And if, let's say, you are titrating the strong acid with the weak base, which means your solution will be acidic. And then in that case, you will be using bromothermal blue. And then if you are titrating the strong acid with a strong base, that is your methyl orange. Then can we have a look on November 2022 question paper? The first question there, ethanoic acid is a weak acid. That is a keyword. That is the keyword. Ethanoic acid is a weak acid that reacts with water according to the following balanced equation. And then we are given an equation. Then our first question, it defines an acid in terms of Lorentz-Bronsted. So you respond in this way. An acid according to Lorentz-Bronsted is a proton donor. And if you are talking about proton, you are referring to H plus ion. Then secondly, give the reason why ethanoic acid is classified as the weak acid. Then the keyword there is the weak acid. Remember I said earlier that if you are talking about acid, the keyword in acid is that acid ionizes. So we say now ethanoic acid. Ethanoic acid is a weak acid because it ionizes. It ionizes partially in water to produce a low concentration. To produce a low concentration of hydronium ion. Okay, let's go to the second question. The second question, write down the formula of the two bases in the above equation. That question also requires the reaction analysis. Then ethanoic acid in that equation serves as an acid, water serves as a base. After ethanoic acid donated with proton on the product side, it becomes the conjugate base. After an acid has accepted a proton on the product side, it becomes the conjugate acid. So in this case, 7.1.3. Our first base is water. The second one is CH3COO minus. Then let's go to our our question 7.2. Question 7.2, a flask contains a 300 centimeter cube of a dilute sodium hydroxide. Let's highlight dilute sodium hydroxide of concentration 0.167 mole decimeter cube. I want you to understand the first keyword there, dilute. It means that there is a small amount of base in proportion to the volume of water. Then let's go to the question. The question, it calculates the number of moles of sodium hydroxide in a flask. So we are going to use that equation. C is equal to N over V, where C stands for concentration, N stands for number of moles, V stands for volume. And in the statement we are given the concentration. We are looking for number of moles. We are also given the volume, but the volume we are given it in centimeter cube. So conversions are necessary in that case. So we can simply say 300 times 10 to the power negative 3, or we say 300 divided by 1000. Then the answer there is 0.05 mole. Then let's go to the next question. The next question there, it's ethanoic acid of a volume 500 centimeter cubed and an unknown concentration X is now added to the flask to give the solution of 800 centimeter cube. One, it means that these volumes are additive. It is found that the pH of the mixture is 11.4. So we are given the pH of the final solution. Then from the pH of the final solution, in this case, it tells you that our resulting solution is basic, and we are going to get the number of moles of the base in excess. So we go to our pH equation. pH is equal to minus log of concentration of hydronium ions. It is very key, candidates, that when you substitute in this equation, if you are substituting above the pH, you change the square brackets into round brackets, because the square brackets in chemistry, they mean a concentration. Then, as I'm summing up my lesson, we are going to substitute with the pH by saying 10 to the power negative pH, which is 11.4, is equal to concentration of hydronium ions. And then from getting the concentration of hydronium ions, we are going to substitute that value into a kW expression. Thank you so much, candidates.